So in surface chemistry we are discussing in that. So what we are completed in that, adsorption is over, second one catalysis is over. Now we are discussing about colloids. See, what is the meaning of a colloid? Colloid is nothing but similar to solution only. So already we know solution means what? Solvent plus solute. So it is what? Homogeneous mixture. It is a homogeneous. Now instead of solution you take a colloid. So instead of a solvent, this one you called as a dispersion media. Next, solute you called as a dispersion phase. But the difference it is heterogeneous. So means how you can identify means two components you add. So you after mixing you can't get anything, then it is called as a true solution. If you mixing two compounds, after mixing you are identify something is there in that, then you called as it is a colloidal solution. Next, what is the main difference in these two? That is the solute particle size and dispersion medium size. So if dispersion phase is nothing but a solute, particle size is 1 nanometer. 1 nanometer to 1000 nanometers is there. Suppose in meters means 10 to the power of minus 9 meters to 10 to the power of minus 6 meters. This much of size is there means that you called as a colloidal solution. Next, we will discuss about classification. Classification of colloids. So how the colloids are classified? So one is the physical states. So physical states of dispersion phase and dispersion medium. One is the physical states of dispersion phase and dispersion medium. So second category, that is types of particles. Types of particles of dispersion phase and dispersion medium. Dispersion phase only mainly important. Next, third one. So third one, the attractive forces, the attractions between dispersion phase and dispersion medium. So first one we will discuss. So the physical states. So physical states of dispersion phase and dispersion medium. So first, so here in entrance also the important that is dispersion medium plus dispersion phase and their example. So these are important. It is first dispersion medium. So dispersion medium you take all solid. Next, solids. Next, dispersion phase, solid, liquid, gas. Next, fourth, liquid plus solid. Fifth, liquid. Sixth, liquid gas. Next, seventh, gas, solid. Eighth, so gas, liquid. So total 8 types we can classify based on the physical states. So that examples are important. So solid. So what is that? The example is gemstones. So colored stones, so otherwise gems. Means the small amount of solid present in large amount of solid. So that is. Next, second example. That is a dispersion phase means a solute. So it is a liquid. So small amount of liquid present in large amount of solid. So that is what? Gels. Otherwise paste. So liquid is small, that solid is large. Next, gas is a small amount present in the large amount of solid. So that means, so pumice stone, otherwise foam in rubber. So the foam of rubber. Also examples. So examples are very, very important. Next, the small amount of a solid is present in large amount of liquid. So that means, so small amount of solid present in large amount of liquid. So that you can take water. Paints. The best example is paints. Next, small amount of liquid present in a large amount of liquid. So that is emulsion. So emulsion, milk is the best example. Next, small amount of gas, large amount of liquid. So small amount of gas present in large amount of liquid. So that is what? So example is foam. So foam you can take. Next, small amount of solid present in large amount of gas. That is smoke or dust. Smoke, otherwise dust you take. Next, small amount of liquid and large amount of gas. By seeing you must visualize. So that is clouds. So clouds, mist, fog, these all are coming under this. So in entrance point of view, the examples are very, very important. Next, second classification. So types of particles. Types of particles of deep dispersion phase. So again, these are what? Multimolecular. Multimolecular. Next, second one, macromolecular. So next, third one, associated. Associated soul, otherwise colloids. So multimolecular. Multimolecular means what? Large number of atoms. Large number of atoms or small molecules. Small molecules are associated, aggregated. So that is called as, suppose best example, any metal soul you can take. Metal soul. So that is gold soul or silver soul or platinum soul, that are coming under. Next, otherwise sulfur soul. So S8. So sulfur particles present in water. So that is coming under multimolecular. So next, macromolecular. Macromolecular means large amount of, means large mass. Large mass of dispersion phase. So best example you can take starch, otherwise polymers, synthetic polymers dissolved in the suitable dispersion medium. So gum, so starch, so that are coming cellulose, so enzymes, everything, cellulose, enzymes dissolved in water, etc. Next, associated. So associated means these are the best example is measles. So what the measles means? Soaps and detergents. So this is very important. Now we will discuss about that. So that is associated example, that is measles. So here, so it contains a large chain of hydrocarbon. It is ended with either positive charge, otherwise negative charge. So hydrocarbon. So hydrocarbon, this is what? Non-polar. So non-polar tail. Next, polar heads. See, these are very small particles. So lowest concentration means you can take as pure solution only. But if in a particular concentration, you called as CMC, critical micelle concentration. Next, that Kraft temperature. And Kraft temperature, the temperature at which that soap particles, this is contains soap particles are converted into micelles. Otherwise the minimum concentration at which that soap particles are converted into micelle. So what is the micelle means? So around that, so all are accumulated at one place. So all positives. So all soap particles are accumulated. Otherwise, you can take negative also. So the association. So the association of soap particles. So it is called as micelle. So that Kraft temperature and CMC, critical micelle concentration, the soap particles are converted into like this. Next, what is the difference between soap particles and detergent? Soap and detergents. See, the same thing, hydrocarbon chain is a long chain only, but here what? COO minus, K plus, otherwise Na plus. So ions. So this is covered with positive, covered with negative. So this is so surrounded with positive negatives. So large chain positive surrounded with negative, large chain negative surrounded with positives. See, next, what is the detergents means? You can take SO3 minus, that is covered with K plus or Na plus. So sulfates, otherwise positive means you can take ammonium, that minus, Cl minus or any negative charges. So longest hydrocarbon with N. So otherwise that is COO minus and with potassium. Otherwise sodium. So generally sodium we are using means that is detergents, means our cloth soap. Potassium we are using means our toilet soap. Next, cleaning action. Cleaning action of soaps. Say, actually, our dust. So, dust is maybe present in inorganic dust. So, inorganic means a full positive or full negative charge. Next, organic dust. So, organic dust means grease, petrol, that are grease, petrol, diesel, kerosene. So all are present on the cloth. So dust, the dust is best example of inorganic. Suppose the cleaning of inorganic. Suppose we are taken cloth. Our cloth contains dust particles with full positive and full negative as a dust on the surface of the cloth. So now what happens? We are treated with soap. So then what happens? The soap contains that hydrocarbon negatives. Negatives are neutralized with positive. Next, positive soap particles are neutralized with this. Next, positive dust is neutralized with negative soap. Negative particle is neutralized with positive. Next, you are pushing more pressurized water. High pressurized water you are using means so this neutralized particles are separated out. You will get a clean cloth. So clean cloth, the foam is going outside. So that means dust particles, soap particles, they are going outside. This is inorganic dust. Suppose organic dust. Suppose organic dust means the clean cloth. The grease particles and petrol, these are stains like this on that. So here, that what? This is organic. This hydrocarbon chain also organic. So that's why what happens? Your soap is added means all the chains are going inside. Hydrocarbon is attracted with hydrocarbon. So all are going inside, minus, plus, whatever it may be. So that is neutralized by again their other charges. Minus is there, plus, minus, plus, minus, plus, minus, plus. So next here also you put high pressure of water. See, these hydrocarbon chains are entering into grease and that they are removed with high pressure of water, that everything is removed and you will get a clean cloth. So now we will discuss the preparations. So preparation of colloids. So one is chemical method. See, first of all, you must think who are forming colloids means that ionic compounds are readily dissolved in the water. So they are not easily forming. That they are forming true solutions. Suppose you take D block elements. D block elements, D block element sulfides, otherwise sulfur, they are easily forming colloids. So now we will take example. So that arsenic oxide, it is treated with H2S. So that is metal sulfide. That will be otherwise heavy weight of P block elements with sulfur. So what happens? H2O eliminated. So you are getting As2S3. So this is the sol. Plus water is eliminated. So this is what? Double decomposition or double displacement. This is a double decomposition. So otherwise a double displacement. So balance means try to balance this one. 3. That is. So next, otherwise you take oxidation process. So oxidation process means So any sulfur oxide plus H2S. See here, sulfur it is the colloid. So you are adding H2. It is oxidizing agent, it is reducing agent, water will go outside. So sulfur you are getting H2O. So 2 sulfur. So 2H2O means 2 oxygens, so 2H2 is gone. Next 3 sulfur. So this is what? Sol. So that is oxidation. So according to this it is oxidation. Next, otherwise reduction process means gold sol. So AuCl3. So AuCl3, you remove the chlorine. So in what way you can remove? So oxidized or reduced, anything. So aldehyde plus water. So we are heated. So then what happens? The oxygen is going to here. So that means what? Aldehyde become as acid. Hydrogen is removing the chlorine. So you are getting what? Gold sol. So the gold is dissolved in water. So here chlorine is eliminated as HCl. Next, here O is coming. You are getting HCOOH. So that you can take, we are adding water. So you can call it as hydrolysis. Water is adding hydrolysis. So it is. Actually, we are concentrating this one only. So the best one is what? Reduction, reducing. So reducing process, oxidizing process, double decomposition, otherwise. So the D black elements means FeCl3, ferric chloride, you hydrolyze with water. So what happens? FeCl3 is replaced with FeOH taken thrice. So this is also not dissolved in water. So this is also colloidal solution. So you can, only water you are adding, so that's why you called as a hydrolysis. So we can prepare the colloids in chemical method. So anything you take. So always you remember who are the colloidal solutions. So large size and which are not dissolved in water. So that means what? D black elements, otherwise P black metals, their sulfides. Sulfur itself. Next to gold, platinum, silver metals, they are not easily dissolved in that. So here also D black element hydroxides. Next, second one, electrical disintegrated method. This is Bredig arcs method. So Bredig arc method. Say suppose you want to create gold sol. So gold sol means you are taken a beaker. Next, it is surrounded with ice. So that is ice cubes. Next, one gold plate, and here also gold plates are connected. So it is covered with water. So one is connected with a positive electrode, another one is connected with a negative electrode. So now we are increasing the potential. So then what happens? The heat is generated. So this electrical charge, heat is generated at this temperature, highest temperature. What happens? It becomes as vapors. So the gold plates at this temperature, they become as gold particles. So the gold particles are dissolved in the water. So this is water. We are taking this. So the gold particles are vaporized, that are surrounded with water. So then it becomes as a colloidal solution, that only gold solution. Next, third preparation, that is peptization. See, peptization means suppose any chemical reaction. So the product is going to solid form. So that is called as a precipitate. So when precipitate is forming, that time you add suitable electrolyte. We are adding a suitable electrolyte. So then what happens, that particular time the precipitate become as a colloidal solution. So complete precipitate means that is coming to the bottom of that test tube or beaker, whatever it may be. That time you are adding suitable electrolyte, that is not become as precipitate, it become as a colloidal and surrounded in the solution only. So for best example, suppose this electrolyte you called as a peptizing agent. Called as a peptizing agent. Suppose one best example you take silver nitrate, very diluted. So diluted silver nitrate solution is added with diluted potassium iodide. Diluted potassium iodide. So then what happens? Ag plus I minus, they are going to become as a precipitate. So AgI. So but here what happens? This iodine particles also surrounded around AgI. So actually iodine is not surrounded means AgI is going and precipitate. In the meanwhile, whenever it becomes as silver iodide, in the meanwhile only iodine minus are surrounded. So it becomes as a colloid. Next concept, purification. So purification of a colloidal solution. So purification of colloidal solution here. So mainly the three important are there: dialysis, electrodialysis, ultrafiltration. So first one we are writing dialysis. See, actually colloid. So how the colloid is forming? Suppose the peptization last only we are discussed. So colloidal is forming. So colloid contains some electrolyte will be there. So colloid contains some electrolyte. Some electrolyte is there means again because of this plus and minus charges the colloid will be neutralized and colloid is going to damage. So we are protecting of colloid means what? In that colloidal solution what are the excess electrolyte you remove, that is the purification of a colloid. So in this dialysis means we are taken a beaker. See, in this we are taken so one middle chamber, so that contains a porous membrane. We are taken a porous membrane. So from this membrane only electrolyte solvent particles only moving outside. So we are sending water. So the inlet is water. So outlet water is going. So here we are taken colloidal solution. Next, small dot particles. Dot particles are our electrolyte. So this is large particles, you can feel colloid. Suppose we are sending water. Slowly, this is a semi-permeable membrane. Semi-permeable membrane, otherwise, so any paper, that what? Cellophane paper with small holes. What is the use of this one? Only electrolytes. Electrolytes only coming outside. Large size of particles cannot coming outside. So with high pressure of water we are sending means all these particles are coming outside and they are going to outside. So then this will be safe side. This is called as we have dialysis process. So next, electrodialysis. Second one, electrodialysis. See, this means suppose we are adding only water means it will take longer time. These particles are not easily coming outside. This process is very slow. Suppose the same phenomena, one side we are adding positive, another side we are adding negative. So connected with electrical charge. So then what happens? Here negative particles are coming this side, positive particles are coming this side. So then what happens? That all electrolytic particles are fastly coming outside. So then inside colloidal solution will be purified. Next, third, ultrafiltration. One method is there. See, ultrafiltration. So ultrafiltration process. See, we are taken filter paper. So holes are very large. Ordinary filter paper. So ordinary filter paper has a large size. So then what happens? Colloidal solutions. Colloid plus electrolyte mixing. So we want to remove this electrolyte. Suppose ordinary filter paper you take and colloidal solution you are putting means colloidal particles also going through these holes, electrolytes also going to this. So this filter paper we are converted into small fine holes of the filter paper. So then what they will do, they are mixed with colloidal. This is added with colloidal. So this is the material. So colloidal material is what? So it is 4% of the nitrocellulose. 4% of nitrocellulose, the solvent mixed with ethyl alcohol. Ethyl alcohol, otherwise diethyl ether. That mixing solution. So now it is poured on that. Next it is dried with formaldehyde. So added with formaldehyde and dried. Formaldehyde adding, and after we are doing dry. So then what happens? The filter paper, the holes are become as very fine small holes. So the big holes become as small holes. So this is called as ultra filtered paper. So now colloidal solution you pour on this. What happens? Electrolytes only going down. This large size colloidal particles are stopped on the surface of the filter paper. So they can easily separate out. See, in the classification of colloids, we are missed in the discussion of that nature of classification of colloid based on the nature of attraction. Nature of attraction between dispersion phase and dispersion medium. See, previous 3 times we are classified. I explained physical states also, next types of particles also, we missed this one. So according to this, the attraction force, see, between dispersion phase and dispersion medium, attraction is very high. So attraction is very high means this is called as lyophilic soul. This is called as a lyophilic soul. If attraction dp and dm attractions are less, then it is called as a lyophobic. See, philic means attraction, leo means solvent, lyophobic repulsion. So this is, see here, attraction is more means suppose dispersion phase has a positive charge. So that is, you take dispersion phase surrounded with dispersion medium. This is again surrounded with dispersion phase, dispersion medium. So it is continuously moving. So here what happens? Dispersion phase, one layer only surrounded with dispersion medium. Next it will be stopped. So here what happens? Suppose positive is there, it is neutralized with negative. Negative is there, neutralized with positive, negative. So continuously it is going. So charges, what happens? It is less. So charges are less. Here one positive, one negative. Charges are more. So here charges are less means you are connected with electrical current. So means what? These are not moving. Not moving towards electrodes. If you apply current, these are not moving because of what? Positive charge decreases, neutralized with negative. Again negative is decreases. Continuously the charge is decreases, at last it is disappears. So here what? Full charges are there. So that's why easily moving towards electrodes side. Next, here what happens? More layers are possible. So here less layers between the dispersion phase and dispersion medium. So that's why this is what? Stable. So because of this strong connection, so it is stable. So what happens? This is, it becomes as unstable. Next, if you want to remove this one, layers, negative layer, positive layer, continuously you are removing, means more electrolyte is required. So more electrolyte is required to separate the dP and dm. Here only 2 layers. So electrolyte. So less amount of electrolyte is required to separate the dispersion phase and dispersion medium. Next, what are the examples for this? Means you can take glue, starch, water, gelatin, that are coming under this. So next, here what are the example? Gold sol or silver sol or platinum sol, otherwise sulfur sol. So that are coming under. So weak attraction forces between dispersion phase and dispersion medium. Generally you take water. So less attraction with water. That is. So next, what about this surface tension? This surface tension is very less compared to dispersion medium. Suppose starch powder you are mixed with water and you pour above side, then what happens? The perfect circles are not coming. So that means the surface tension is less. You take gold is dissolved in water. How much gold is dissolved? Suppose gold dissolved in water also, you can feel as gold type only. So that's why this surface tension is high. So one important point.